Now, coming back to the experiment, that is what he found is that what he got is that this particular he got the observation on the photographic film. He got 3 spots. I have taken 3. You will be getting so many spots, but I am just considering 3 for my what you can say that is explanation. I have considered that we have taken 3. Otherwise, innumerable spot you will be getting it. Understood? You cannot take innumerable and you can describe it here. For that reason, for my simplicity to explain you, I have taken 3 spots here. That also I am telling you. Alright, otherwise you will be thinking how 3 spots only will be coming. Many spots will be there. Many. Alright. Now, next is, that means if you draw the lines from here, one line is straight. Here you can see that. One line is bent at an angle. Alright. This angle is much more than this particular angle, you can see that. This angle. This angle is much more, this angle. That means from here I can conclude that this particle which is bending towards the positive plate is what charge? Negatively charged. Alright, it is negatively charged. Definitely. Because if it is bending towards the positive plate, means the particle has to be negatively charged, because like charges repels and unlike charges attracts, you know that. And definitely this particle which is bending towards the negative plate means it is which charge? It is positively charged, first of all. Now, next is, as it is bending much more, got it? The angle is more. I should have drawn a little bit more. The angle is more. That means this particle is a lighter particle, because lighter particle bends more, because it travels much more faster, the lighter particles. Alright, clear? For example, 2 persons is there. One heavier, another is thin. Alright, person is there. Suppose you are pushing it. The thinner one, you will see he will little bit oscillate, but the heavy one, they will stand in the same place only. Same thing here also I am explaining. This is a lighter particle. It makes more angle. It deviates more. The deviation is more. So by that we can prove that it is a lighter particle. This particle, and this particle is a heavier one. So deviation is less. We can say that. Clear? So hence this particle which is negatively charged, which is lighter compared to this particular particle, was named as beta rays, we can say, or yeah, beta rays also we can say that. And this one we can call it as alpha rays, we can say that, or alpha particle we can say that, or we can say beta particle. This one which is having negatively charged is beta particle, and this is alpha particle which is having positively charged. And the one which is going straight, it is not bending either towards the positive or to the negative plate. That means definitely this is neutral in nature, has to be, because one is bending towards the positive plate, another is bending towards the negative plate. This is not bending towards the positive or the negative plate, it is going straight. That means it is neutral in nature. So this one was named as gamma rays. It was named as gamma rays. Got it? Now, later on, the symbol was given to it. The symbolically it was said to be as, beta rays was said to be as -1 E0, same as that of electron. Alpha rays was 2He4, means it's a doubly ionized helium atom. How did we come to know it is 2He4? Because the alpha rays, the mass was calculated 4 times that of a proton or a hydrogen atom. The mass was. What is the mass of proton? 1.672 into 10 to the power minus 24, what you can say, kg. So it was 4 times that of the particle, the alpha particle, the mass was 4 times that of a proton or a hydrogen atom. And the charge was twice that of a proton. The charge is, you know that, 1.602 into 10 to the power minus 19 coulomb. So charge was double of that of any proton, and the mass was 4 times that of a proton. So hence it is considered to be as a helium atom, because helium charge is twice that of hydrogen and the mass is 4 times, we can say, that of hydrogen. So hence it is considered to be as alpha rays as doubly ionized helium atom, we can say that. Clear? Now, next is gamma rays has got no charge, no mass. So hence its symbol was taken to be as 0N0, we can say that. No charge, no mass. Alright, why it is no mass? Because its penetration power later on was seen that it is maximum. It can penetrate through, gamma rays is so penetrating, it can penetrate through 30 centimeter thickness of iron. It can penetrate, you can't imagine how much thick it is. So in this way, 30 centimeter thickness of iron, it can penetrate. It is so highly penetrating, gamma rays, because it has got no mass, almost 0 and 0, no charge also, neutral in nature, highly penetrating. Its speed is similar to that of the speed of light. Got it? 3 into 10 to the power 8 meter per second. It is considered to be as electromagnetic in nature. Got it? Gamma rays. We can say that. Electromagnetic rays. It is coming under that also. Got it? Under electromagnetic rays, gamma rays comes under it. We can say that. Now, next is as it is highly penetrating, it has got no charge, it has got no mass. Got it? It travels with the speed of light, 3 into 10 to the power 8 meter per second. Got it? Compared to alpha and beta rays. Alpha rays, as it is having more mass, it is having more kinetic energy. Alright, so the velocity is quite less. Got it? Velocity is quite less because it's a heavy particle. Velocity is quite less. And compared to that, the beta rays has the velocity similar to that of that is what you can say similar, means almost closer to that of gamma rays. We can say that. Clear? Almost closer to that of the gamma rays. Clear? So in this way, this by this experiment, Rutherford came to this particular conclusion for the first time that radioactive particles has got three, what you can say, that is can be subdivided into three categories. We can say that alpha, beta and gamma rays, where alpha rays is positively charged particle, beta rays is negatively charged, and gamma has got no charge and no mass and highly penetrating in nature. Rutherford concluded this. Got it? Now, next, so this was Rutherford's experiment. We can see that. Clear? I said you, it was being done at the same time. There is Madame Curie, Pierre Curie and all these things. So all these things, got it? Now we are coming to the discovery of neutron. That is James Chadwick. We'll come to it. Now Chadwick, before doing the experiment, got it? Before doing the experiment, he studied all these things. He studied Rutherford's experiment, Madame Curie's, Pierre Curie's, Henry Becquerel, got it? That is Goldstein, then Thomson's, all the experiment is studied. So one thing was very clear to Chadwick, alright, it was very clear to Chadwick that apart from positively and negatively charged particle which has already been discovered, there are some neutral particles was also being present in it. There was some neutral particle. How did he come to know? Gamma rays, which is neutral in nature. Otherwise, we would have got two rays, alpha and beta, where from this gamma is coming. So the scientists are of the opinion that Chadwick got the idea for this discovery of neutron from this experiment. Initially I told you, from the Rutherford's experiment he got this particular idea. That yes, as it consists of the neutral particles, which is nothing but the gamma rays. So he was sure that an atom consists of positively, negatively and neutral particles is also being there. And he did the experiment and he found it out, the neutrons. Got it? He found the neutrons. He discovered the neutrons. But the idea, he got it from here. Suddenly, see, remember it, in science, nothing comes suddenly. It is always after some or other research. Alright, you need to do research upon it. So as I said, before Chadwick, it's not that yesterday night he got a dream and the next morning he discovered it. No, he did several years of research he did it. He studied so many things. Then after that he came to this conclusion. And to ascertain the conclusion, he did the experiment. Now he did his own experiment. He did his own experiment and he finally concluded. He discovered neutron and he concluded that yes, an atom consists of electrons, protons as well as neutrons, which is neutral in nature. We can say that. And the mass of the neutron is this, which I have already discussed with you in the previous AV. I have said you all these things to you, that how neutron was discovered by James Chadwick. Alright, clear. In this way, some chemists or the scientists believe that Chadwick got this idea from here. Alright, clear. So, I have already discussed with you the Rutherford's atomic model. I have discussed with you the drawbacks of the Rutherford's atomic model. I have discussed with you Thomson's atomic model. First, of course, Thomson, then, of course, Rutherford, because Thomson's student was Rutherford. Got it? Now, before going to Niels Bohr's atomic model, before the development of the Niels Bohr's atomic model, many more things was being developed. Many more things was developed. Many more what you can say advancement took place in science, in chemistry, we can say that. Clear? What are those? Now, development leading to the electromagnetic radiations or the electromagnetic waves. Got it? That, or we can say the electromagnetic wave theory, we can say that. It led us to the, after the discovery of the electrons, protons and neutrons, or before the discovery of, before the Niels Bohr's atomic model, many more things was developed. So one of the development was electromagnetic wave theory or the electromagnetic nature of or electromagnetic radiation of an atom, we can say that. Now what is that? It is said that when you are heating any particular substance, any substance, for example, let us say this is iron rod, I am heating it. What you find is that upon heating it red hot, it glows, it gives out light. Alright, it's giving out light. When iron, a metal, when you heat it, what happens? You will see it glows, it gives out light. So that light is considered to be as electromagnetic in nature. Alright, so first point is that when you are heating any particular substance, alright, then you find it gives out light. Or suppose the white light, the source, alright, or the sunlight, it also gives out light. It is also believed that when sun is heated and we are getting the light, because for that particular purpose, when the sun is at noon overhead, you can't see the sun. Alright, you can't see with the naked eyes in the sun, you can't look at it in this particular way because it's very, very hot and it gives out such a strong beam of light that you are not able to look at it. You know it, all these things. Alright. In this way, so whenever you are heating a particular thing like a bulb or an incandescent flame or a metal or a sun or any source of what you can say white light, it gives out light always when it is heated. Point number one. Point number two, the radiation which is being given out by this heated filament or whatever it is, alright, or metal, it nothing but is electromagnetic in nature. We can say that the radiations. That means it consists of electric and magnetic field because the radiations is in this way. Got it? It has got some waves. You have read in physics. This is nothing but the crest and the trough which I am drawing it here. The crest and the trough. Now what I said you, this consists of electric field and magnetic field which are mutually perpendicular to each other. Alright, because how these waves are created, in this way the waves are created. Because it consists of electric field and magnetic field. Let us say this is your electric field and let us say this is your magnetic field, which is mutually perpendicular to each other. The angle you can see I am drawing it is 90 degree. Alright, the angle which I am drawing it here, you can see it is 90 degree. It's made up of this electromagnetic waves. It's made up of two fields, that is electric field and magnetic field, which are mutually perpendicular to each other. How do we come to know that it's electric and magnetic field? Because it gets deviated. Already we have studied in the cathode rays that it gets deviated towards electric field as well as it gets deviated towards the magnetic field. We can say that. So hence it is electromagnetic in nature. We can say that. Now as you can see in the this here, the radiation possesses which character? Wave character. Just now I was saying that it consists of crest and trough. It possesses wave character because this is a wavelength. I have drawn it here. Alright, consisting of crest and trough. It possesses wave character. Alright, and these rays can propagate through any medium. It can travel through vacuum also. Yes, sun rays is electromagnetic rays. 95% of the distance traveled by the sun is through vacuum, is through space. So hence, what you find is that these rays do not require any material medium for propagation. It can travel through vacuum also. Alright, so this was the few of the points which was put forward by the electromagnetic wave theory, that when you are hitting any object, it gives out light, radiations. These radiations are electromagnetic in nature because it consists of the electric field and magnetic field which are mutually perpendicular to each other, and they travel with the speed of light, which is 3 into 10 to the power 8 meter per second. That also proves that it is electromagnetic in nature because light travels with this particular speed. And also this particular waves, what you can find is that it possesses wave character, it possesses wave nature, and also you find that it can travel through any medium. It does not require any material medium for propagation. Alright, nice. Now we will discuss that, as I said to you, that it possesses wave character. If it is possessing wave character, that means it has got wavelength, it has got wave velocity, it has got wave number, it has what you can say got amplitude, it has got time period, it has got frequency. We are going to understand all these things now and the relationship between them. Got it? Thank you.